This video illustrates to you how to choose the minimal sample size to control the error of the estimation of population mean. The problem is this. A soccer ball manufacturer wants to estimate the mean circumference of soccer balls within 0.1 inches. Determine the minimal sample size required to construct a 99% confidence interval for the population mean. Assume the population standard deviation is 0.25 inches for part A. To understand this problem, first of all, find the maximum error. E is equal to Z alpha over 2 times sigma over square root n. This result applies when n is large, n greater than or equal to 30, and the population is infinite or large enough. And what is Z alpha over 2? It's given in this picture that the standard normal curve, where 1 minus alpha is the area in the middle, then alpha over 2 at the tail. And you can find Z alpha over 2 from the table. Examine the question again. We are given that you want the error to be within 0.1 inches. So this is the error here. E 0.1 inches. Okay, we want to find the sample size n. And we are 99% confident that the population mean will fall inside the interval, assuming that the standard deviation is 0.25. Sigma is equal to 0.25, and we know the formula for error is Z alpha over 2 sigma over square root n. Now, what is Z alpha over 2? We go back to the diagram again. So we are going to get 99%. So in the middle area is 99%. So left with 1%, evenly distributed to the tail. So this is 0.5%, and the other end 0.5%. So if you draw the standard normal graph, where the center is 0, and the tail is 0.5%, that means the center to Z alpha over 2, the area is 49.5%, which is equal to 0.495. Now, if you check the table with this area 0.495, so 0.495, the nearest is 2.58, where you have 0 and 4951, which is the nearest. So I'll get the value of Z alpha over 2 is 2.58. So making use of Z alpha over 2.58, we are able to find the n now. So to part A, the maximum error is 0.1. Z alpha over 2 is 2.58. Sigma is 0.25, and n we don't know. Let's find out the n here. So square root of n is equal to 2.58 times 0.25 over 0.1, 6.45. And so n will be square of 6.45, 41.6. So you take n equal to 42. This is the minimal sample size you should take to ensure that the error of the estimation is within 0.1 inches. Now, part B, what if the standard deviation is 0.3? And what will the sample size be? So for part B, E is still the same. Z alpha over 2, sigma over square root n. Now, E is 0.1, Z alpha over 2 is 2.58, and sigma is instead of 0.25 is now 0.3. Square root n, and you find that square root n now is equal to 2.58 times 0.3 over 0.1, and you get 7.74. So n equal to is 59.9. So you take n equal to 60. So the conclusion is, if you have a greater standard deviation, in order to achieve the same error, then you have to take a larger sample size. The explanation is this: if sigma is increased, then the variability increase in population. Therefore, the larger sample size is needed to ensure the desired accuracy.